Question 4, Part A. In the diagram, ABCD represents a garden. The sector BCD has centre B and angle DBC equals 5 pi over 6. The points A, B and C lie on a straight line and AB equals AD equals 3 meters. Copy or trace the diagram into your writing booklet. Part 1. Show that angle DAB equals 2 pi over 3. Since the question's only worth 1 mark, we'll keep the reasoning brief and to the point. I've recreated a part of the diagram for the purpose of explanation. Now points A, B and C are collinear. That means they lie on a straight line. That implies that adjacent angles on that line are supplementary. They add up to pi radians or 180 degrees. So angle DBA plus angle DBC equals pi. So angle DBA equals pi minus 5 pi over 6, which equals pi over 6, and the reason is supplementary angles. Now angle BDA equals angle ABD, which equals pi over 6. So that's these two angles marked here, and I've marked in the size of those angles. And the reason is base angles of isosceles triangle DAB. So if we consider triangle DAB, AB equals AD, that's given in the question, which means the base angles are identical. That leaves us angle DAB, which the question is asking us to show that it's 2 pi over 3. And we'll use the angle sum of a triangle theorem. That is, the angle sum of any triangle is equal to 180 degrees or pi radians. So angle DAB is equal to pi radians minus pi over 6 minus pi over 6, and that equals 2 pi over 3 as required. Part 2. Find the length of BD. There are two methods we can use to find the length of BD, and in this solution I'm going to show both methods. Now in the first method, I'm going to rely on the fact that an isosceles triangle can be divided into two congruent right-angled triangles. Now the question is asking for the length of BD, so if we divide the isosceles triangle by drawing an altitude, so this is altitude AE, dividing it into two congruent right-angled triangles, that means BE equals ED, and if we consider just one of the right-angled triangles, noting that the base angle of the isosceles triangle is pi over 6, and then using regular right-angled trigonometry, so SOHCAHTOA, we can find the length of, say, BE or ED, and then double it to find the length of BD. So dividing it into two congruent right-angled triangles and considering this triangle here, or either triangle for that matter, so triangle BAE, cos of pi over 6 is equal to adjacent over hypotenuse, so BE over 3, and I've stated that here. So rearranging this equation to make BE the subject, we get BE is equal to 3 times cos pi over 6. Now cos of pi over 6 is an exact ratio, which is root 3 over 2. And then we double 3 times root 3 over 2 to get the length of BD. So BD is equal to 2 times 3 times root 3 over 2, and that gives us 3 root 3. Therefore, BD is equal to 3 root 3 units. Alternatively, by the cosine rule, we have BD squared is equal to 3 squared plus 3 squared minus 2 times 3 times 3 times cos of 2 pi over 3, which equals 18 minus 18 times negative 1 over 2, which equals 27. Taking the square root of 27, we get BD is equal to root 27 or 3 root 3 units. Part 3. Find the area of the garden ABCD. The garden is a composite shape made up of an isosceles triangle and a sector. So area ABCD is equal to the area of isosceles triangle DAB plus the area of the sector. Now since we have two known sides and the included angle in isosceles triangle DAB, we can use the area rule to find the area of that triangle. And that's half times 3 times 3 times sine 2 pi over 3. Now for the area of the sector, we need the sector angle, which is 5 pi over 6, and we need the radius of the sector, which is 3 root 3 meters. So the area of the sector is half times 5 pi over 6 times 3 root 3 squared. So the area of garden ABCD is equal to half times 9 times root 3 over 2 plus half times 5 pi over 6 times 27, which simplifies to 9 root 3 over 4 plus 45 pi over 4, We could have factorized out the 4, but it doesn't matter at this point. Therefore, the area of garden ABCD is 9 root 3 over 4 plus 45 pi over 4 square meters in exact form, or 39.24 square meters, correct to 2 decimal places.